So again, let's kick this off. Again, welcome. This is our August edition of the CTO Office Hours. And the whole point is here, we're bringing in our experts. So we've got our technical team here, Andy, Leon, and Stacy, deep expertise, and they're here to answer your questions. So again, we've got some demos lined up today, but I don't want us to be held into that. These really work well when you ask questions. So I'm Steve Perchnewski. I'm a Director of Product Marketing here at Vast, and I'm joined by our Field CTO team. So Andy, you want to introduce yourself?
Hi, everybody. Andy Pernsteiner, Field CTO for Vast.
Awesome. And Stacy?
Stacy Brown, Global Solution Specialist, focused on analytics here at Vast.
And Leon?
Hello, I'm Leon Clayton. I'm Field CTO responsible for advanced analytics. Nice to meet you all.
Excellent. This team has got a really awesome background from data analytics perspective. Leon and Andy came from MapR. Stacy came from Starburst. So, jump in, ask your questions. This is a fantastic opportunity. So, before we kick things off, let's start with, again, our agenda is your questions, right? So, we will build it off of what you ask. With the analytics expertise on this team, we're going to lean heavy into the database today. But I want to start with a poll. So, what we want to ask is, where are you on your AI journey today? Everybody is excited about this. Everything's exploded. We know people are scrambling to find GPUs. So I want to give this just a minute, and this is going to help us gauge our conversation. So yeah, I'm already watching this come in, and it's coming in about where we expect it to be. Just give this about 30 more seconds. So how many people have participated? Boom, we've got some people in production. A lot of people are on the edge of production. But most people are still, on the cusp of just getting started. So, Andy, Stacy, and Leon, is this about what you expected to see as well?
Yeah, I think obviously what we're seeing is that people are early in their journey, and even if they've started working on it, that it's still in the experimentation phase and really learning about what they can find.
Like, what are people telling you are the barriers to getting started?
There's a lot. Honestly, many times you find that the expertise required to build and manage AI pipelines is something that is not common in the marketplace. And so right now there's a big push for people to upskill themselves and to learn about how to do all of these things. And it can be quite complex.
Yeah, and I think that's a good segue into why did we unveil our vision of a data platform. The idea is here, we are trying to simplify this to democratize AI for everyone. So the data platform really unifies compute, data, storage, services all into like a simple unified platform rather than kind of an aggregation or an integration. So hit the next slide if you don't mind, Boone. What it does is we're really unifying object, unstructured data, structured data in the form of tables, along with compute services in the form of triggers and functions. And then we're also building this across a global namespace that just really abstracts away a lot of complexity and lets you get faster to starting to do artificial intelligence and bring value. So Andy, I thought your demonstration at our Build Beyond event really kind of like illustrated the difference between a unified platform versus, say, an integration of unrelated components. So I wonder if you could kind of dive into a little bit about like contrast that versus an integration.
Sure. Yeah. So if we go to the next slide. I think what we found when looking across how people are building AI pipelines, MLOps pipelines, the choices that you have available to you are effectively to take buckets of parts, whether they be in the cloud or on-prem, and assemble them into a series of pipelines and create an environment where you can start to do AI and machine learning at scale. The challenge is that there's all these different systems that have to be managed. And oftentimes, even just for structured data like databases, you have many choices because there are many different use cases for different types of databases. There's many different use cases for different types of unstructured data storage. And so people often wind up with many different independent data stores for each part of their application, and they have to manage them all independently, and they have to come up with a way to move data through them. And oftentimes there's a lot of inefficiency in the sense that data is copied. Data has a lineage challenge. When you have data in multiple places, it's often challenging to understand what the true source of truth is. And so this is the challenge that we've seen a lot of people face. And then it multiplies as you start to realize that nowadays it's not enough to be able to collect and analyze data in one location. You oftentimes have to do it in many locations. And doing so means that you have to duplicate efforts across a wide area. And so if you wind up with many different siloed applications and many different siloed data centers or cloud providers, it's just a lot more to manage. And it becomes important to have people who know how to manage all of those pieces. But honestly, that isn't where the value is derived from AI and machine learning. It's not in assembling all the parts. It's not in managing all the individual components. It's actually deriving insight from the data. And all of those issues that people face trying to stitch these all together create a world where it's difficult to manage. Now, we contrast that to what our approach is, and ultimately VAST is out to build the next generation data platform. And there are a number of components to it, and I'm not going to go through all of them in detail here, but I wanted to focus a little bit today on the database. So VAST has created a database that is native to our system. It is part of our ecosystem and is not anything different than the rest of our platform in the sense that it's scalable and it allows for a lot of different types of applications to be run on it. The goal, of course, is that it can replace many independent database systems so that customers only have to deploy one. It's in sync with the rest of the platform, meaning the data store, which is effectively how we store all unstructured data, as well as the data space where we stitch it together across multiple geographies, and the data engine where we can run applications on it. You go to the next slide. Just to sort of reiterate on it, the VAST data platform here in the center is where we see customers running these pipelines, running these applications. And of course, we don't own the entire stack, right? There's the application layer where you'll be developing your own tools and applications to do your analysis, to do your learning, to create your models. We're not creating those things for you, but we are creating a platform where they can be run. And you know, initially when we started out as a platform, we were very careful to choose the right hardware to make sure we got the best possible performance and economics out of the system. And so we've extended that now to be able to do so across a much wider variety of hardware, including in the public cloud. So basically, when new hardware offerings, when new technologies are available, we can layer them in underneath the rest of our platform and allow customers to take advantage of it. You go to the next slide. And ultimately, the way it looks is like this. We have controlled the state layer, right? So VAST has been in business for a little over 5 years and has been able to deploy exabytes, in fact, maybe over 10 exabytes at this point, of managed capacity to customers. That was just our start. So we started at the state layer, storing files and objects. We've extended the platform to store tables, and now we're introducing the ability to have functions and triggers that are run against that data to be able to allow you to do things with that in a more intelligent way. We expose the data over standard interfaces, including file sharing protocols, as well as database interfaces to execution engines. And then we have the ability to run functions directly on the platform that are based off of events and triggers that can be initiated when new data lands or when new conditions are met. You can go to the next slide. Now, it's one thing to deploy this in a data center, but it's another to be able to stitch it together across multiple geographies, multiple types of data centers, either the edge or the cloud or some combination of all of them. And what we've found is that customers no longer have a single place that they can put things. It's not just that they have multiple data centers, but they now have to also leverage the cloud. And it's challenging to manage all of those things without having a way to unify them together. And so what we've done is created a way to do so. If you go to the next slide. By using what we call the data space. So the data space is VAST's global namespace, which allows for all files, all objects, all database tables, in fact, all functions and applications to be run against a single platform regardless of how many geographies it's stretched across. So think of it like a mesh where data which lands into the mesh can be accessed or processed by any application that's anywhere else in the mesh. And the idea is that users, developers, and application owners no longer have to think about where the data lives versus where the compute lives. They can run compute where it makes sense. The data will move if it needs to, and we will make sure that all applications are able to see a consistent view of the namespace, regardless of where they are. You go to the next slide. Now, one thing I wanted to do is kind of highlight the integration points here. I know I'm talking really fast, but it's because I want to give you guys some time to see the content that Leon and Stacy have put together. We've covered this before, but what I wanted to underscore here was the fact that VAST has a catalog, which is inherent to the system, where anytime new data is ingested, it's automatically indexed and all of its metadata is indexed into a catalog, which is accessible using high-speed SQL queries. And the goal here is to allow you to not think of your file system and object store differently than you would think of a database. The ability to be able to query against metadata in your file system in real time whenever new data is ingested is the point of having a catalog. And it doesn't require a separate system that you have to manage, and it doesn't require that you have to go and set anything up. It's automatic and it's already built in. This is just the first instantiation of us using our own database technology to allow the file system and object store to benefit from it. And so actually, I'm going to hand it over to Leon, who's going to show you a quick little demo to talk about this.
Somebody had brought up, one of our founders, Jeff Denworth, brought up the point that when we introduced this, no one asked what it was. Like, I think people may have assumed it was, an external database, but no one really asked, it. And that's kind of the key point here, right? That this is actually built into the system. It's integral, it's unified versus something that's external. So I think it's a good point to bring up and kind of drive home.
Hello, everybody. Can you see my screen okay?
Looks good, Leon.
Cool. So nice to see you all today. So starting in version 4.6, as Andy's pointed out, all data, all objects, they're automatically indexed in the system and placed within a VAST table. So this can be quickly and easily looked at and queried by various tools. And today I'm just going to show you some of those fairly quickly. If you've got any questions, please put them in the chat. So you can see here, this is the VAST VMS here that we have. And the first thing I'll show you inside here is, by default, big catalog is what we call this. Big catalog is enabled. Big catalog will take snapshots of the systems at intervals. We work out the differentials, what's changed within them, and we publish all those changes, whether they're deletions, creations, whatever they are, and they go within the database. So we keep all these. Now we've got set attributes that we have in here about the files and objects, and we'll go through those. But I wanted to highlight today, but I'm not going to demonstrate user definable attributes. There's some really good demonstrations on YouTube by Andy of the user defined attributes and how you can use those in pipelines to trigger processes, etc. So you're not limited to just a standard set of attributes on it. You can extend this and use this within your data flows and workflows. Okay. So that's that part. There are a few things within VAST. VAST has always had very good capacity usage graphs. So the ability via this to look around the file system, look in there, see for data reduction rates for different types of workflows and different data are in here. So at a high level, you can see the overall space usage of the system from a usable or logical unique perspective, which is very good. I've also had very good usage of being able to look through the system from a data flow perspective from end users right the way through the system. So you can see where the data is being done by bandwidth, IOPS, etc. But what the big catalog enables you is to get the granularity of the objects and files themselves. So first off, we're going to jump into side here, and we'll jump into this big catalog section. There's one inbuilt query tool. It's not the most wonderful tool in the world. It's not scalable, but that's where I'll start, and then we'll go over and start using some more interesting tools and show you what's capable here. So I'm going to open the query panel here, and I can just build a query up. So the first thing is owner. So I'm going to search for owner's name is exactly Leon. Let's see what I own on the system. So I can execute this query now, and you can see I've got a lot of stuff. You can see the columns that are there with parent, path, name, size, etc. as you go across. So you see a lot of fields within here. So I've got everything that's owned by Leon. I want to also know anything that's size. I want to know by size is greater than 10 meg. So let's have a look what's got inside there. So these aren't finds of the file system. These are queries on the big catalog, which has been built up. So you really get fast response. So you can see here, we've got quite a lot. I have got a lot of files on the side of here. I've got more than I should have on this system. But I'm actually looking for some PDFs. So at this point, we can then look for extension is exactly PDF. Add this to that query and execute this query.
So Leon, it doesn't matter if I've got billions of files, right? The search is still going to be the same speed because I'm not actually going and crawling the file system, correct?
That's correct, Steve. And this didn't respond as fast as you would think there, but remember, this is just an inbuilt single-threaded type execution engine. Mm-hmm. The ability I'm going to show you in a minute to use external engines, that's really where you can start to use the power of SQL. Okay. There are also Python extensions you can get to this from, and there's an API you can use. So there's a lot of different methodologies so you can use this programmatically. So you can see in the end here, we've got, all those PDFs as we asked for, over 10 meg that Leon owns. Very simple in that term, and it doesn't really put any load on the system to do that. Okay. Now I'm going to stop sharing quickly, and I'm going to jump over to another window. So I do apologize here while I just swap things around. I've only got one monitor due to a broken monitor. So that should be it.
Now, I was going to ask a question about how do we control permissions to this, Leon, in a way? I've got multiple users on here. What's the method of making sure that people only find the data we want them to find? That's
a very interesting question. I keep sharing the wrong screen here. I do apologize here. I'm having a few.
We see your CLI there. That's what we want to see, right?
Yeah, it's actually the wrong CLI.
Okay, sorry. You got more than one CLI going. All right.
You can tell this is live. No, stop that. That's the completely wrong one. I do apologize for everything that's happening right now.
Oh, no worries. But I mean, the point is it exposes a lot of flexibility. And because kind of as we just popped past there, right? We saw that SnapDiff one. That's another really interesting use case where the idea is that we can now just what changed in the last couple of weeks, right? That's really powerful.
Yeah. So I mean, this is the interesting. The access controls on this are via if you're used to use S3 user identity policies that are in AWS, they're the same thing. We use identity policies to identify users that can access the API and query this information.
Gotcha.
So granular access into here, etc. So hopefully we've got the right CLI now. We can see that. So here we go. So the first thing is I've got a Trino cluster inside here. So I have an external Trino cluster, which I can go in and have a look at. At this point, I can start to do a search within this. So I'll just do a simple describe from an external query engine via a connector to the VastDB. And you can see here as a description, this is the database, this is the schema, and this is the actual table for the big catalog. So you can see everything we're seeing through the GUI. You can see all the handles, the M times, the C times, etc. And if you add any custom attributes, they would show up here as well, so you can query them via this method. So of course, when you've got a proper SQL engine on here, you can start to do a lot more interesting queries. So let's have a look at some of the things we can do here. First one, show me all the biggest files across the system, just the top 10. So there we go. Hopefully there's no too dodgy names in there. But you can see down here the size, and this was instant response. Show me the biggest files. Normally, like scanning file systems and trawling it for this system for this type of information is quite painstaking in the way to do this. Other interesting queries, I won't show you too many today, but show me all of the tables, symlinks, files, schemas, the numbers that we have within the system. Obviously, this is a smaller system and it's worked often, so we don't have a huge amount of information inside there. We have the usual queries that you do, what I've showed you before. So show me all the files owned by, just have to alter this one, by Leon. So I find this interface much more friendly because it's quick, it shows up. But then you're able to do lots of usage, show me all the total disk usage by all the users on the system. And there's creative. What I've found is business logic is SQL. So, excuse me, being able to write SQL really means you can explore what's going on within the system and start to see lots of changes. I'm just seeing whether there's anything interesting else inside here. Retrieve the top 5 owners and their parent paths. So some of the queries do get quite creative, and we love being creative with them within VAST. But you can see within here, this is a bit of a more complex query. This is Trino that's actually querying this at the moment. And you can see here, who's the owner, the parent path, the file count, and the total size down that path. So as creative as you can be. Now, that's not the end of where we will go with this. There are other things we can do within here. And I'm going to exit Trino quickly here and clear the screen. Now, Jason Russell has been writing some very interesting stuff we've put on GitHub for doing snap diffs. Now, snap diffs, in this context, I'm just going to run them. Snapdiff is a Python we made available. We can list the snapshots, and we're going to go to VMS, which is the control point for the whole cluster for VAST. So by simply running this, I can see all of the snapshots that are available. You can see here I only have the big catalog tables that are available at the moment, but I have them for the period that I have specified to keep them. So it seems fairly straightforward, but then you can do some creative things like the following, which is show me every file that's been created for the last 24 hours. 24 hours is the default. You can specify times on this, so you can specify time periods, and that will show you exact files that have been created within the last 24 hours. That could be the last 5 minutes, the last 10 minutes.
Yeah, I wanted to jump in on a question here. We have a question from Raj, and he had a question about seeing the read access for files. So I apologize. There have been questions popping up here, and I had a sticky on my monitor that covered that up. So I'm glad to see these questions coming in.
So it's interesting. So obviously we've built the database. Now we're going to show you a demo of the database in a minute. The first thing to use the database is the big catalog, which is this feature we're demonstrating now. Now, we already have access logs, etc., that are stored within the system. So who's accessed what, who's accessed this. The next, in a very soon upcoming release, those audit records, if you want to call them that, will also be in a table. So you'll be able to query them. I mean, at the moment, they're in JSON, in JSON format or CSV, I can never remember. That's it. That could be easily inserted, but we're going to do that for you. So the next one that we'll release will have that. And then if you think about that, Andy touched on this, looking at where files have come from, their history, who created them, who's touched them, where they've gone. That's very difficult to do. But what you have here is, once that's completed, almost a complete system of record for what's happened on the system. Okay.
Good. Thanks.
So that's the end of this part of demo, unless anybody has any questions to say.
Yeah, let's go ahead and jump into some of these questions, since I kind of let these slide by here. So there's a question from Roger. He's wondering how this works across multiple VAST systems.
So each endpoint would actually just be its own database. So you would query those endpoints. I don't think, I mean, unless Andy or Stacey have got a better thought, I don't think we've thought of the amalgamations, but they could effectively be virtual tables within a larger construct. Is my instant answer to this. Is you can, in a lot of tools now, you can have virtual tables. That virtual table can be made up of multiple physicals, is the way I start to think about that.
Yeah, from an integration standpoint, we're going to unify these to some extent so that regardless, if a cluster is part of a data space, meaning it's in a relationship with other clusters, then the catalog for all clusters will be accessible, and there will be an overlay table, as it were, that will point to virtual tables, as Leon pointed out. So you can run a query that will go across all of them. That's not yet implemented, but it is part of the plan.
So another question about, could we run these queries as a reoccurring policy, say end of the month reporting? I think that kind of dives into some of the iterative compute that we want people to do with the VAST database.
Yeah, I absolutely agree. Yeah, definitely.
Yeah, and if customers have like reporting that they already do, let's say, for example, they use something like Tableau or Looker or some other reporting tool, there's no reason why that reporting tool couldn't be configured to talk to the vast catalog and pull out that information on whatever frequency that they want. Yeah.
I'm actually going to show that in a minute, Stacey.
Yeah, I think that dives into another question from J. Ray Scott. He's asking, could this be integrated with a discovery system like Varonis? And it's open APIs, right? So there's no reason we couldn't let an external application crawl this through, through a controlled manner.
Absolutely. Then you just do that.
Makes sense. All right. And then there's another really good question. How much space does this take up? Is this consuming additional space on the system as we create this catalog?
It does create it, but it's very efficient. So in the VAST system, we have very good data reduction rates. Oh, have we lost somebody? I think we lost Andy. We have very good reduction rates. So we do a combination of compression, dedupe, and also similarity reduction. So within these tables, there is very high data reduction rates that happen. But yes, it does consume space, but it is only a high level. It's not the actual data, it's just an overview. And I'll show you this with a demonstration in a minute with packet captures, which will show you, how efficient that space can actually be used. But yes, it does consume space. Sorry, we sell storage.
There's another question here about, does this do full text search of PDFs, or can it integrate with Elasticsearch?
I think that's actually one of the use cases one of my colleagues has been working on, where there's OCR software, where you can use the demonstrations, and we're not going through that today. Andy's used this a lot there's some things on YouTube already covering it, but using this methodology to find files which have landed on the system, which haven't been processed, which could feed OCR software to then extract the text. Now, depending on when that wants to go, you might need to put that in a text search type engine, Elasticsearch or something that gives you additional functionality and indexes. That we don't have indexes in here yet. So it can be used as a trigger mechanism to do processes, but not necessarily good for plain text search password searching like that implies.
Makes sense. So you want to go ahead and maybe we'll go into Stacey's section where she kind of dives a little bit more into how this works, and we'll keep kind of feeding these questions in as we go through. And I hope my sound canceling is working well, because the neighbors are getting their lawn mowed right now. So
let me
know if I need to mute.
You're 100% good. So go ahead and go to the next slide, Steve.
All right.
We're going to start by just sort of setting the stage here a little bit and telling you that, first of all, when we set out to build a database that's embedded into the VAST platform, we're looking to try to solve a lot of the challenges that we saw out in the industry. So the next couple of slides here will be a little bit of a history lesson, so to speak. But the main thing to take away here from this slide is that we're really aiming at trying to simplify what people do traditionally in data engineering. So we're trying to create a system that does really, really well at real-time streamed analytics, as well as cataloging in real time. And we're trying to eliminate, or we have so far eliminated, a lot of the decisions that have traditionally had to be made by data engineers in order to get the most value out of the data. Go ahead to the next slide, Steve. So when you look at this slide, classically, when you've had different types of systems in the past for storing data, you had transactional systems that were used for your production operational type of databases, and you had analytical systems that were used for, you had your data warehouse that was used as the place that you ran analytics against your data. And the reason for that was primarily because the data across each of those different workloads was stored in a different format. So for your production databases, your transactional processing databases, that data was stored in row format, whereas your analytical data was stored in more columnar format. And there was very good reasons for that on both sides. Based on the workloads, you had to store the data different ways in order to have it be easily accessible and get the most out of it in a short period of time. And so we took a look at this and we said, all right, how can we create a system that does really well at both of these things combined? And that's really what we set out to do. So we created a system that allows you to, oh, and by the way, in the past, people were making architectural decisions based on your traditional hard disk drive storage. And there hasn't been a lot of thought put into how these applications can be rewritten and redeployed taking into consideration all the benefits of Flash. There just hasn't traditionally been a lot of thought put into that. So that's really where we targeted when we set out to create the database specifically and everything else on top of that. So at a storage level, of course, you store the data in different, not quite there yet, Steve. At a storage level, when you think about the different types of storage, you had different types of storage for workloads that were small random IOs and a completely different set of storage for large sequential types of IOs. And they were largely built on top of shared nothing architectures where you had a series of nodes that had direct attached storage on top of them. And this created, when you were running these queries against it, whether it was transactional or analytical, that created a lot of communication between each of the nodes in order for them to make sense of the data. So there were just a lot of dependencies, a lot of cross-talk across all the different nodes before you got your end result. And that created a lot of challenges, both in terms of performance and in terms of what you could do in a short period of time. So go ahead to the next slide now, Steve. And then on top of that, of course, we've evolved in the software stack, and now we have modern applications. And in these modern applications, many of which were created within the cloud, you have things like MPP engines, such as Trino and Spark, where you have a distribution of a number of different nodes that are accessing data that has, because it's on the cloud, is just written into object storage, and object storage on the cloud is still backended by hard disk drives. And so in order to obfuscate or minimize the performance that you see from hard disk drives and from this slower object storage that is very cost efficient, there was this layer of caching that got created inside each of the nodes on the application. Of course, this added another layer of complexity into the mix. It was one more thing to have to manage. It also added an additional layer of cost, et cetera, et cetera. So we are looking to try to eliminate all of that for you guys and really simplify how you do data engineering and how you access the data to do analysis. Go ahead to the next slide.
Stacey, I wanted to jump in with a question here. We've got a question from Lynn Ma, and he's asking, what is the user feedback, kind of real world? As you mentioned that complexity, we've had some people, I've watched some conversations you've had where this resonates with them, right? Where there's kind of the data engineering that goes in. Some of our customers have actually, we're not just making this up out of the blue, right? We're actually building this with customers. This is a problem they're facing.
Yeah, I mean, the first thing that a lot of customers have done is sort of give us, hey, let's go ahead and I want to see how it works with my specific data, right? We've done some benchmarking, so I can talk a little bit about some of the benchmarking that we've done. So customers have taken their data, they've tested it, they've run it against queries, and just speaking, it varies per customer. But if I talk about like the benchmarking, most traditionally known TPC-DS, the workloads that we've done there, we've seen on average an improvement in query efficiency. And by query efficiency, I mean, if you look at the number of rows that are input into the query engines versus output to the query engines, the amount of rows, so we've written plugins for certain applications to be able to talk to the database. Some of those are just APIs you can use. Some of them are for applications such as Trino and Spark. But net is we're offloading some of the processing down to the vast database, and we're just much more efficient at it because of the way that our architecture is on the back end. And of course, like Andy indicated earlier, the metadata database is embedded into the application into very fast storage class memory. So it's extremely efficient and extremely fast. And it gives us the ability to get access to the data more quickly. And we're going to actually talk about that in the upcoming slides and some of the things that we're doing that are different than what's been done in the past.
Perfect. Thanks.
Yeah. So on this slide, this sort of double clicks on the pain of data engineering, what the world we've been living in so far. And if you look at and use Parquet as an example, which most customers have some level of Parquet files, it's very popular in the data and analytics space. But in Parquet files, you sort of have to do this dance of, okay, I have a certain analyst that's trying to run and get information out of the data. And depending on what analytics job he's running against the data, there may be a need to size those Parquet files to be very large row groups or very large Parquet files versus very small Parquet files. And every time you do that for each individual consumer of that data, you end up having to rewrite the data, reformat the data, and store it differently. So you're constantly having to make these decisions on, do I create very large files? And if I do, I get great compression. That's really good. But by storing them large, if I'm looking for something specifically, I have to scan the entire row group. So that can be inefficient if you're doing a highly selective query. And on the reverse side, if you decide to store them very small, because you maybe are doing more selective things, now I have a ton of IO because I have to open and close each one of those files. I also give up compression efficiency. So these are the types of balance that the data engineers have been having to go through. And it's been a major pain point, and it has impeded productivity in terms of being able to do analytics. So go ahead and go to the next slide. So when we looked at this, we said, all right, what is a way that we can give customers a single platform that will allow them to do both transactional and analytical within the same system? And the way that we did that was first and foremost by creating this database that I'm going to go into deeper in the next slides, but the way that we store the data, the way that we access the data. Of course, we're doing real-time queries. You have events that are coming in. We're storing them in objects and files, and now we have functions that can access that data. Go ahead and go to the next slide. And actually, Steve, in the interest of time, let's just skip through the next couple of slides and go straight into how we ingest and get data into the database. So for this, whoa, well, really fast.
One back.
So if you go back to how data gets into the database specifically, and I'll walk you through it for the big catalog. When data gets written into VAST, first it goes into a write buffer, if you will, the storage class memory. The data is written into a row format, and then we acknowledge the write back to the application. From there, we wait and destage it to low-cost flash. And when we write it to low-cost flash, we're actually writing it down into columns. And even better yet, in the next slide, you're going to see we're writing it into very small element sizes that allow us to do some really interesting things. So data comes in. So in your logs, for example, those get written to the array. They then get ingested into the database on the back end, and we then write them into a catalog with metadata information that's written into what our VAST database is on the back end. So
Stacy, at this point, there's a question from Viv, and he's asking, does compression and dedupe and similarity do data reduction? I thought similarity was the only one used because it combines the best. So during that migration process, what's happening from a dedupe or data reduction perspective?
It is both, it's compression, it's deduplication, and it's similarity across all of them. So we do all three before we store the data down.
Perfect, thank you.
And I wouldn't call it inline because we acknowledge the write back to the client, but it is happening before we write it down to the low-cost flash on the back end. So go ahead and go to the next slide, Stephen. I want to try to get to Leon's demo here where it will resonate. So when you think about Parquet, just taking lessons learned from Parquet in the past, traditionally Parquet's best practices has been to create row group sizes that are somewhere in the 256 meg chunk size. When we write the data down into our database, we're using a much, much smaller element size of 32K. That's like 4,000 times smaller than any Parquet row group, which means that when you're going and accessing this data and trying to pull back very specific pieces, we're going to send back smaller amounts of data back to the clients to need to be processed. Go ahead and go to the next slide. And so essentially when too fast. So when the data gets written into the database specifically, we're storing it in these 32K chunks. And as part of those 32K element sizes, we're also storing metadata information, things like min and max, things of that nature. We're also doing distributed sorting and filtering so that we're grouping the data together as much as possible so that when you do run those queries against it, the response back from those queries is quicker. It's much quicker than you would have otherwise if it were just, say, in a data lake, for example. Go to the next slide.
So before we move on, there's a question about latency. And is there an answer? Because these are really optimized for flash storage, right? These are too small. They wouldn't be efficient on hard drives, right? This was built for our NVMe flash. So how does this affect latency of query?
Latency
this may be the right slide to be on.
When you run a query, you're running it against specifically the database. So we have to, the only latency is getting the data from, let's say you're writing it into a Parquet format file. We do have to import it into the database before you can get the optimized query performance initially.
Excellent, thanks.
You're welcome. Okay, so let's go ahead and actually the next, so this comparison is just intended to compare, like if we were to do Parquet row groups that follow the standard recommendation of 128 megs versus vast database chunks, we're at a much more granular element size. So if you go to the next slide, that just lends itself for, oh, sorry, go back. That just lends itself for doing extremely well at very selective queries. But that said, like I mentioned earlier, when we did benchmarking, industry well-known TPC-DS, we saw across the entire TPC-DS for 100 terabyte data set, we saw anywhere a speed up for query performance and completion time in seconds, anywhere from 40% to 61% improvement in query performance by using the vast database versus say, and this is important to note, versus running a query on S3, so using an equivalent query engine running against S3, but even that S3 was on VAST, which is already flash storage. So even for flash optimized storage on S3, we saw anywhere from 40 to 61% improvement in query completion times.
So that brings up a good point. And Rukshan has a question about, can this be used with Hadoop? So you can just start using us today with S3 without necessarily adopting the database, if that's where you want to start.
Yeah, and that's something that we're talking to a lot of customers about in helping them, crawl, walk, run, first migrating off of Hadoop, getting into S3, getting comfortable there. And then eventually, the most benefit is going to come from them importing their data into the vast database, where they're going to get the smaller, they're going to get the benefits of having the metadata database that they can query to access the underlying data more efficiently at a smaller element size on top of that.
And there's a whole bunch of questions here about, can I get a lab to play with this? Do we have a vast sim, or is there some way that people can start playing with this now? So there's about 4 or 5 questions in here. I think I may have dismissed someone's question before I answered it.
Yeah, I would say today we don't have a simulator that I'm aware of. I'll let Andy and Leon speak to that in case I missed that. But we do work with customers to either give them access to our labs if they want to do some testing. We've also shipped equipment out to customers if they want to do some testing in that way. So we have lots of different ways to get you a chance to get comfortable with what we're doing with the vast database.
We actually, you can deploy in EC2 in AWS. And so we can also work with customers to get credits for EC2 hours so that you can do so at no cost, but you'd have to work with you individually on that.
There was a question from Anne that I think I hit answered, and I didn't get a little prematurely. In general, what kind of onboarding ramp does this have to install an existing system? So if you're already running VAST today, all you have to do is get to VAST 4.6 to get to the database, correct?
Yes, you have to get to 4.6. You have to configure the database. So it's got to be set up. The database has to be configured. And then from there, we have to get data into the database. So there's got to be some sort of import of whatever data you want to test, importing that database. At least that's how we are now. In the future, I see us probably coming up with ways to automatically using those functions that Andy mentioned earlier, ingesting data directly into the database, but we're not quite there yet.
Okay, makes sense. And there's another question here about export tools. If we have to create a sandbox in AWS for on-prem data, so how are we getting that data in there?
If you create
well, there's a couple options here. So if you have a VAST system on-prem, then we can leverage the data space to allow for that data to be accessed in AWS or EC2. If you needed to export data from another system and bring it in. Typically, if you do so, if you export it into Parquet format, if it's already in that format, that's the easiest way, then you can ingest that into a bucket in S3, and then we can import it from the data that you have stored in S3 directly into the database. So there's a couple different options. The easiest one is if you already have a vast cluster in another data center and you want that data to be accessible in the cloud. But if you don't, then just export it into Parquet and shove it into a bucket.
Okay, makes sense. All right.
Steve, go ahead and go to, I think, what is the last slide before we hand it over to Leon to take us through the demo. This is just a high-level representation for you guys to give you where the database actually sits. So the things I want you guys looking at here is at the top, we have different mechanisms for importing the data into the database. That's under that little importer box. We have various different query engines that you can use to access and query the database outside of our own API. In the middle here, you see this is where all of the vast data platform sits. You have your metadata database, like I mentioned earlier, that's your embedded into storage class memory to quickly access the data. And then of course, under that, your elements are all stored into all flash memory in that really small element size. And just like Andy talked about earlier, you can access it on-prem, at the edge, or in the cloud. So a lot of flexibility here in terms of what you can do.
So there's kind of a big question here. Eric Kavanaugh is asking, is Pure Storage our most direct competitor here? What are your thoughts about a data fabric, which ideally incorporates intelligent automation and facilitates fast access to data? I think this is a good kind of big picture, place to answer that question.
Yeah, I'm happy to. First of all, I worked for storage for 8 years, or I worked for Pure Storage for 8 years, and I can tell you right now that I don't view Pure Storage as our biggest competitor in this space. And the reason why is because Pure is still acting and behaving as just a storage company. They do not have any sort of database embedded or any sort of efficiencies in terms of how they store the data on the storage outside of just being a storage platform. So we're bringing something much different to the table than Pure has thought of that I'm aware of.
Yeah, I would agree with that. I think this is really unique. And I think that's one of the challenges here is getting people to see it for what it is, right? Because there is not anything quite like it on the market. So I think that's really interesting. So we've still got a few more questions here. To use VAST style Parquet, do customers need to replace their client lib with a specific header? So there really isn't a VAST style Parquet, right? We can work with regular Parquet or.
So, and to be fair, it's not VAST Parquet. We just recognize and read in Parquet file formats. We see those Parquet file formats and then we ingest them. We take all of their header information and use it as metadata. And then we write from the Parquet file, we write the actual data into our own element store. There is no VAST Parquet.
Right. I guess, talk about moving from Parquet to our table element, but the truth is that you can do either or, right? So you can continue to work with Parquet if that's what you like, or you can go to our more efficient element, which again, like you mentioned, like it gives you a huge boost even over just Parquet on S3.
Correct.
Let's move on to the next one, and we'll go ahead and keep trying to weave some of these questions. And thank you all for asking these questions. These are fantastic. So we're going to pause for a poll here. So what is your current tool of choice for data analytics? What are you all using? And I think this also leans kind of nicely into the next demo. And again, we'll kind of pause for a minute here and ask, the panel, is this what you expected to see? While that's going on, here's a question from the beginning that I missed. Without having compute local to the data, your performance will be restricted by your connection path to the data. It can have a huge impact. How do we deal with this? So Andy, that kind of gets into our data space message from the beginning about being able to optimize where we run our processes against data.
I think there's a wider point there, really. I mean, days of local storage to compute are Hadoop when you were limited to 1 gigabit networks. I think when you transition to 25 gig and above, then the latency and the speed of those networks actually becomes faster than a local bus do. Therefore, when you transition that point, that for me becomes less of an issue. And you can then get better performance when you start getting up to faster networks. So I think it's a legacy left over, to be honest with you, Steve, on that one.
Okay, makes sense. So looking at the results, a lot of Databricks, a lot of Snowflake, some Trino, Dremio, Spark, and Hadoop. So Leon, how do people get started? Like, what's the easiest place for people to come over? What's the transition point to start using our database?
There's a couple of things, and Stacey covered them nicely. It's basically steps. Do you want to go straight in? If it's a new use case, a new thing, then design it around the database and use the advantages of it from day one. So that's new applications, and I'm dealing with a lot of customers and how to write the schemas, what's the best flow, how to use our technology. Coming from legacy, where you're perhaps HDFS, how do you get that then just start in the transition to S3? Don't alter the data, just use S3 instead of HDFS with fast networks. And then once you're happy with that and you identify things, then you can move over to the database. So I think there's two different approaches here. I like new use cases fit better into going straight into the database.
Makes sense. All right, let's jump over to the demo. So a question here about sizing. Do we, when using Vast Database, how much additional compute would you recommend adding to a cluster? So are there sizing considerations here for analytic workloads?
Yeah, there may be. You may be pulling through there. You may need an additional C node, so C box, but compared to where it was without, but it's not massive. But there is a consideration there, yes.
Okay.
That's the beauty. You can add those easily, and that's the cheapest part.
Right.
Okay, let me hand over. Let me share my screen. Hopefully this will be a little bit more seamless. Can you see that okay? Let me just move this around. Good. Yeah, that's cool. So back to the cluster that we looked at earlier. I'm going to go and start exploring some of the sections here now. So you can see within here, we touched the big catalog, but I'm going to touch the database section now. This is a view of the database, and you will not see the big catalog database in here. It's a hidden one. But you can see in here now, there are various schemas that have been created. Remember, we hold the metadata as well. So we have a place to store the metadata. And you can see inside this schema, there's Leon. Somebody's created weather with lots of tables, and somebody's created a wetter one, which I thought was quite funny earlier because they can't spell weather. But you can see within here, and there's some things I'm working on here where you can start to look at the definitions of the tables. So you can add them and create the columns here if you see fit. That's not what I'm going to do in the demonstration here. I'm going to show you the way we would do this. And for here, we've actually just created a quick new demo. I'm going to go to the second tab. Can you see the second tab has popped up? Is that sharing okay?
Yeah, looks good.
For this demonstration, basically, we have a 3-node Trino cluster, which is on the other tab here. It's attached to the database via the Trino connector. I have a Tableau client. I also have a client here, which is just doing a local packet capture. You can see the Trino cluster is fairly quiet at the moment. And coming down, I've got some simple commands here. I'm going to show you here. This is creating the simple table, and I'm going to do that on another window because I don't want to stop sharing and keep sharing. So effectively, I'm going to use that, and then I'm going to create the table. So this is a simple table I'm going to create, which would have timestamp, source IP, destination IP, the protocol, and the packet size. So very simple. Now, if I go back over here, I'll just do a quick refresh. From that simple creation I did in the other window, you can now see I have that new table within the Leon schema ready to accept data and to be spoken to. So that's how simple it is to create tables, interact with that. Now, before I go back, I just want to show you, I wrote a simple Python script. I am not a particularly good Python programmer, but I can do this. This is as simple as a Trino import, which basically packet sniffs an interface down here using Python sniff, and then it makes an insert inside here. So it just brings this together and starts inserting stuff from the high-speed interface. Okay, so nothing.
I'm going to jump in. There was a Python question a bit back here. Said using this catalog, you'd be able to run Python scripts, calls from a pipeline automation for tools like Shotgun to run file system action. So this is kind of related, right? You're using a Python script.
Yeah, this is a prime example. It's just I'm doing it to do inserts. You can read, and you can read the big catalog. That's as simple as. So on the other window, I'm just starting this script. And you can see now I've started that, oh, well, you can't see, I've started that script, and you'll start to see inserts and collections going within that table. So you start to see things happening. There's not a lot of packets in there. I've parallelized it as much as I can. Okay. Now going back over here, I'll just do a quick refresh on here again. Go back down to that table, and you can start to see we're starting to have data and rows. I know it's not a fast interface, I do apologize, but you can start to see the data coming in and the size of this particular table. Okay. Any questions at that point before we go on to the next stage?
Go on.
Okay, let me just move things around a little bit again. I'm going to share this screen now, which is that one. Can you see that okay?
Yeah, looks good.
Okay, so this is the last client we had. I'll just clear the screen here. And I'm going to go back into Trino. So now we can start having a look inside Trino. So at this point, I'm just going to use the table. So let's just go down to where the table is in the schema. I could have put that in the query, but I'm lazy. So apologies for that. And let's start having a look at what we're collecting within that in the new created. So let's have a look at the top 10. So you can quickly see here from timestamp, source IP, destination, which protocol, packet size as it comes through. So that's really interesting. But with a lot of this, you want to do push down filters, predicates, etc. So there's simple things. You could do time range searches, etc. But for this query, I'm just going to say from now for the last 30 seconds, order by timestamp. So you can start to take slices out of this and just start to bring the data back. And I see there's a lot of time series type use cases or just sequential log file type inputs that this will be very useful for. I see a lot of use of Elastic where you don't use the Elastic features, where this actually could be a benefit. So that, yes, sir?
There was a question from Josh a while back about how latency will grow. So as we scale to exabytes, are we going to see a difference in latency when we run these types of reports or these queries?
I think that depends on the data that's being pulled back. Obviously, there's small amounts now. Depends on the query engine as well, whether you're doing joins or merges. When you start seeing them, you can start to see latency coming from the execution engine. Remember, I'm using external Trino here for the execution engine. Okay, but it is a good question. So simple. Next query is create a list of traffic between source and destination. So you can start to see where the heavy talkers are, where the conversations are happening. So it's a very simplistic demo, but I wanted to show you how easy it is to set up a table, how easy it is to talk to it through Python, and then start using it. And this table could be the vast catalog if you wanted to do things as well. So that's that angle. The next bit, I know we're running out of time quickly. I just need to fire up another window because I think there's a lot of tools out there which are used. And I'll just share this quickly. Yeah. So it's pretty industry standard Tableau. I haven't got Tableau server. This is standalone Tableau in here. And I'm going to connect to that Trino cluster inside here. So you can see, I'm actually using the Starburst Enterprise one, strangely enough, because this is the best Trino connector. It's the most stable Trino connector for Tableau. So when connecting into there, you can now see all of the tables. So I can go and have a look at the schemas within there. So you can see there's a weather and a wetter, still making me giggle. You can also see the big catalog here. So we could, if you wanted to, you can drag the big catalog into your Tableau and start seeing all of the things and start doing stuff. So it depends what your your visualization tool is. This is an option. That's not what I'm going to show today. I'm just going to go back over here, go into Leon. You'll see that, he says, you'll see the packets. Let's drop this over here. Let's do a quick update on those. You can see the data that's still being captured now. Let's go over to the sheet and just do a simple. I am no expert in this whatsoever. Okay, I'll just say that. I'm just going to do packet captures and put a nice pretty graph up so you can see sizes. But I just wanted to show the real benefit. What I'm showing here is the interoperability. It's very easy to use from wherever tool of choice you have. Okay,
that's awesome. So we've got some customers doing some massive packet captures today without the database. So this is going to be really exciting to see how this wraps in. If we didn't get to your questions, we will answer them. We've got your contact information here. I do want to encourage you to reach out to learn more. If you go to deepdive.com/platform/overview. I think you just go to platform. We've got a bunch of different resources that'll help you walk through here and learn more. I encourage you to reach out to your vast sales team. This is a really exciting time. Thank you so much, Andy and Stacy and Leon, for joining. Again, put your questions in here and reach out to us and we'll get back to them. Again, the engagement has just been fantastic. Thank you so much. Any closing thoughts before we wrap it up?
It's all good here.
All right. So we will do this again next month. Thank you so much for joining today. It's been fantastic. And we will get back to you with these questions. Thank you so much for joining, everyone. Take care.
Thank you.
Bye-bye.